question is going to be lots of fun. All right, so our b minus a is going to be 2 and 7, so 7 minus 2 over n as our delta x. So delta x is going to be 5 over n. Now, plugging that in for our right endpoint, we're going to have over here a is 2 plus I times our delta x, 5 over n. So our CI is looking like 2 plus 5I over n. Now, what I really like to focus on is that you are eventually, in your Riemann sum, you are going to have to find f of ci. You know that that is coming up. And with this particular question, it's going to be a little bit of a bear to figure out what this f of ci is. So let's just go ahead and get that out of the way, and then we'll plug it into our limit definition. All right, so here we go. Our f of x is equal to negative x minus x squared plus 1. So if I'm going to find f of ci, I'm looking at 2 plus 5I over n that is going to get replaced for all of those x's. So this x is going to get replaced, this x is going to get replaced. So if I make that replacement with parentheses, I will have negative parentheses 2 plus 5I over m minus 2 plus 5I over n quantity squared plus 1. Now, before I plug into the limit definition, I'm going to simplify this. So I distribute the negative to get negative 2 minus 5I over m minus. Now, this term here, because I have two terms inside that parentheses, I am going to have to FOIL that out. And that is going to be a little bit of a project to FOIL that out. So I'm just going to do that over to the side here, the foiling out of this. So I will have 2 plus 5I over n times 2 plus 5I over m. So when I FOIL this, I'm going to have 2 times 2, so 4 plus, now my outer is going to give us 10I over n. Inner gives us 10I over n. So those are like terms that can combine together to give us 20I over n. Plus the 5I times the 5I gives us 25I squared over, multiplying straight across, n times n gives us our n squared. So this FOILed out is going to look like this. Okay, so again, I kind of go off to the side, figure that out, and then I have in brackets here the FOILed out expression of 4 plus 20I over n plus 25I squared over n squared, and then plus 1. All right, so where do we go from here? We are going to distribute this negative. So when I distribute this negative to all three terms, I will have negative 2 minus 5I over n minus 4 minus 20I over n minus 25I squared over n squared plus 1. And then again, before we plug into our limit definition, we can look at this and say, okay, I have a negative 2, negative 4, plus 1. Those like terms combine together to give us negative 5. And then the negative 5in and the negative 20I over n, those negative 5I over n and the negative 20I over n, those combine together to give us negative 25I over n. And then we still have this negative 25I squared over n squared. Now, remember that these three terms here, those are your f of ci. So we have gone off to the side here and figured out our f of ci, and now we are ready to plug this in to our definite integral. All right, so plugging it into your definite integral, you're going to have the definite integral from 2 to 7 of f of x, so negative x minus x squared plus 1 dx, is equal to the limit of your Riemann sum. So the limit as n goes to infinity of delta x times the sum from I is equal to 1 to n of f of ci. So we're going to plug in our delta x, which we found as 5 over n, and then the sum from I is equal to 1 to n of our f of ci, which again is this three-term expression. So negative 5 minus 25I over n minus 25I squared over n squared. All right, so where do we go from here? Again, once you plug in if you look at our little 4 steps here, once you plug in your delta x and your CI, you want to pull out your constants, split it up so that you get sums involving CI, I squared, I cubed, and so on. So what I'm going to do is I'm going to split this up so that I can get a sum that just involves CI, I squared, etc. So if I do that, I will have the limit as n goes to infinity, 5 over n, and then I'm splitting up this whole big summation. So it will be the sum from I is equal to 1 to n of just -5. Now, the -5 over n, that is a constant because it does not depend on the index I. So I can bring that out in front, and then the sum from I is equal to 1 to n of I. And then the same thing goes over here. This 25 over n squared does not depend on the index, so I can bring that out as a constant as well. Okay, so now I have everything in terms of a constant, an I squared, and the summation. So once that happens, what I can do is I can use my summation rules. So now I'm going to step 2, where I'm using my sum rules. So this constant of -5 summed up becomes -5n. The I summed up will become n times n plus 1 over 2. And the I squared summed up will become n times n plus 1 times 2n plus 1 over 6. So again, that summation becomes -5n, this becomes this, and then that. Now, of course, you still have this 25 over n here, and you still have this 25 over n squared here. Then we have this in bracket, and then 5 over n limit as n goes to infinity. Now, once you have used your sum rules, then your focus becomes on your limit. And to evaluate your limit, you want a bunch of terms that look like a number or a number over n to a power p. So this is where we are going to simplify as much as we possibly can so that we can get those types of terms. So if you look inside of the bracket, these n's cancel. This n is going to cancel out with an n squared to leave us with 6n in the denominator. Now, we're not home free yet though, because we have to simplify this -5n minus. Now, here I want to get a bunch of terms, so I'm distributing as much as possible. So when you think about simplifying, usually it's going to be about distributing. So I'm going to distribute the -25 to the n and to the 1, and I will still have a 2 in the denominator. So this will become -25n over 2 minus 25 over 2. Minus, now, in this last term, so to speak, we have 25 over 6n, and then if I FOIL out this n plus 1 times 2n plus 1, I get 2n squared plus 3n plus 1. And then we still have this 5 over n, and we still have this limit as n goes to infinity. All right, so we need to distribute once again because we have parentheses here. So we are going to have -5n minus 25n over 2 minus 25 over 2 minus. Now, here you'll notice that your 2 and 6 cancel to give you a 3. The n squared over n is just going to give us an n in the numerator, and then we will have our 25. Okay, so then we have minus 25 times 3, but let's think about this as 3 and 6 cancel to give you a 2 and then 25, and then you'll notice this n and this n will cancel. And then minus 25 over 6n. And I do want to just say, I was thinking for a moment, maybe I should have done this. You guys, like, what you can do is you can break this up into 2 steps. So you can say it's like 25 times 2n squared over 6n, and then see that this 2 cancels, this cancels, so you get 25n over 3. That like might be a little easier than trying to do it all in your head. And the same thing goes like for this second distribute step, I have 25 times 3n over 6n. So I see these n's cancel, this 3 and this 6 cancel, so that gives us 25 over 2. And then you can say, okay, this 25 over 6n times 1 just gives us 25 over 6n. Okay, so don't think that you have to do it all together in one. You can totally sit there and like split it up into several little ones and just take it step by step. And that's what I would do when I'm starting out with the problem. All right, so somehow though you got to remove those parentheses. You have the 5 over n limit as n goes to infinity. Now it's kind of up to you. Like you can sit there and say, let me combine terms, but what we really need to do is we need to distribute this one last bracket. So it is certainly true I could combine these, get a common denominator, combine that, but I'm just going to focus on getting rid of this bracket. So this will become the limit as n goes to infinity. The 5 times negative 5 gives us 25n over n. And then minus 5 times 125 gives us, or 25 gives us 125 n over 2n. Minus 125 over 2n, minus 125n over 3n, minus 125 over 2n, minus 125 over 6n squared. Now, the beauty of this is that then things start canceling. So these n's cancel, these n's cancel. When I take the limit of this guy, because there's this n in the denominator, that is going to go to 0. This cancels, this n in the denominator is going to go to 0, this guy is going to go to 0. So what we are looking at here is negative 25 minus 125 over 2 minus 125 over 3. Now, you do have to get a common denominator between all of this stuff. So what your common denominator would be 6, of course. So you would take 25 times the 6 over 6, and that would give you 150 over 6. The 125, 3 times 3, or 3 over 3, minus 375 over 6. And then this guy you would multiply, you get 2 over 2, my highlighter is going everywhere, and 2 over 2, so you would get 250 over 6, minus 250 over 6. So then you would just say 150, negative 150 minus 375 minus 250, and that's over 6, and then simplify that fraction, so you just get 775 over 6. And that, after all that work, that number represents what your definite integral is from 2 to 7. So the definite integral of negative x minus x squared plus 1 from 2 to 7 dx is equal to 775 over 6.